A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be looking at how to perform the third step of configurational analysis, that is fuzzy set qualitative comparative analysis, and the step is calibration of the data. In the previous videos, I've shown in how to transform your Likert scale responses into something which can be used for this type of data analysis. In the second video, I showed you how to do the contrarian case analysis, which is an assumption for performing FSQCA, which is an asymmetrical data technique. Now, we are going to talk about calibration of the data, that is transforming the scores into fuzzy sets, that is between 0 and 1, as FSQCA works on the principle of Boolean algebra. So we will see how to calibrate our data in the software, which is itself known as FSQCA, developed by Professor Charles Raggin. And now we are going to check out how to perform this step. So let us start. The procedure for transforming the variable scores into fuzzy sets. Direct method of calibration is recommended and often used, where the investigator sets three values. It produces rigorous studies that are easy to replicate and validate, as the threshold selection is quite clear. So, selecting the values corresponding to the 0.95, 0.50 and 0.05 percentile of the data will be quite useful, as it will transform the data to log odds metric with all values ranging between 0 and 1. Now, the first step is how to get these percentile values. For that purpose, we'll go into SPSS. Here we are in our SPSS data sheet. We have four predictors or antecedents. One is food quality, cultural authenticity, service quality, and value for money. The outcome is BI, behavioral intention. So, for getting the percentile scores 0.95, 0.50 and 0.05, what we need to do? I'll go to Analyze, Descriptives, Frequencies. In frequencies, I enter all my five variables you see here, four antecedents and one outcome variable. I go to Statistics and I tick on percentile. In percentile, I put 5, 50 and 95 and click Continue, press OK. So you see here, I got the fifth percentile, 50th percentile and 95th percentile values of all my five individual variables. So as you can see in this case, food quality, the value corresponding to 5th percentile is 1, corresponding to 50th percentile is 1.75, corresponding to 95th percentile is 3. Now, we are going to use these values for calibration in FSQCA software. Now, let us go to FSQCA and see how to do this. But before doing that, we need to convert our data set into CSV format, which is taken as an input in FSQCA. It does not take Microsoft Excel input. It takes CSV, comma separated value file as an input. For that purpose, you can simply go to File and then Export CSV data. So once I click on CSV, I can name it and save it on my desktop. That is the way I do it. So I'll show you. I've saved the file here. This is the CSV file you can see. And I can take this CSV file into my FSQCA software. This is the FSQCA software which you can freely download from FSQCA website. Just go to the website and download this software. I go to File, Open, Datasheet, which is in CSV format, FSQCA Behavioral Intention Datasheet, and click OK. So now I've imported that data. You see here, all those values are here, FQ, CA, SQ, VM, and BI, for which we have already taken the 5th, 50th, and 95th percentile value in SPSS software. Now what I need to do, I need to calibrate them so that I can go further with the analysis. I can do a truth table analysis in FSQCA and find out which configurations of these four predictor variables give me the outcome variable, that is behavioral intention. Different configurations. I might find somewhere food quality is absent, but cultural authenticity, service quality, and value for money gives me behavioral intention as an outcome. In other configurations, some other variable might be missing out and others might be present. So there could be different configurations of these predictor variables which help me in getting the outcome which I desire. That is the essence of configurational analysis or fuzzy set qualitative comparative analysis. Not just assessing the net effect of each variable on the outcome, but collectively assessing that which configurations lead to the outcome. And then we look in for necessary and sufficient conditions. Which conditions are necessary? I mean, which predictors are necessary to get the outcome, and which are sufficient to get an outcome. So once we complete this step of calibration, after that, in the next subsequent video, I'll be showing you how to do a truth table analysis, and then we'll be talking about necessary and sufficient conditions. For now, the purpose of this video is calibration. I go to variables, compute, and calibrate. So new variable, I can say calibrated food quality. So I will say CFQ. CFQ is the name given by me to the calibrated value which lies between 0 to 1 for my predictor variable food quality. Similarly, I'll be doing it for all other four variables. Now, in this function X, I'll put this food quality, you see FQ. In N1, I'll put the 95th percentile value, which I got in from SPSS. So let us see what was that. 95th was 3, then 50th was 1.75, and 5th percentile value was 1. So 3, 1.75, and 1. So I'll put 3, comma 1.75, comma 1 and press OK. So now you see you got this calibrated variable of food quality wherein the values, the data scores lie between 0 to 1. Similarly, I'll do it for other four variables as well and get their calibrated values. So I hope this video was quite informative and useful for you, and you learned how to calibrate your data in FSQCA. These are some of the really useful resources. A manual by Professor Charles Ragan on how to do fuzzy set qualitative comparative analysis. A good paper by Papas and Woodside 2021, which describes the steps of conducting fuzzy set qualitative comparative analysis. In the subsequent video, I will be telling you how to generate a truth table and further take this analysis in fuzzy set qualitative comparative analysis software. Thanks a lot and keep watching for more.